Okay, so we're given this iterative formula here. We are told that k is a constant, the sequence is periodic, which means it repeats itself, of order 3, which means there are 3 terms before the sequence repeats itself. So you've got A1, A2, A3, and then A4 would be the same thing as A1, A5 would be the same thing as A2, A6 would be the same thing as A3, and so on. So, A1, A2, which we know is 2, A3, and then we've got A4, A5, and so on. And so this, the fourth term here, we know would be the same thing as the first term here. So if I were to substitute 2 in here, that would tell me what the third term would be. If I'm substituting the second term in here, I'll work out what the third term would be. So I'll do that. So A3 is going to equal k minus 3k over 2, which I can see that is going to be minus k over 2. So that's my third term. And then I could substitute that in here to work out the fourth term. So I'll do that as well. So k minus 3k over minus k over 2. Let's just simplify this a little bit. So times top and bottom by 2 here. So I'll get 6k over minus k. The double negative will make that a positive. The k's will cancel out, and I just get k plus 6 as my fourth term. Now, I could keep going, but actually I don't need to here. Remember that I know the fourth term is going to be the same as the first term. So I need an expression for the first term here, and then I can make this equal to this. For the first term, I know that I can work in reverse with this. Considering that I know that the second term is 2, I could work in reverse to work out the first term. So if I said 2 equals k minus 3k over a1, so substituting in the second term here to work out the first term there. So let's make a1 the subject. If I move this over, let's move that over there, and move the 2 over there, like that. Then just swap the a1 and the k minus 2 round to make a1 the subject, like that. So that's an expression for the first term. And now I know that these, the first term and the fourth term, are equal to each other. So 3k over k minus 2 equals k plus 6. If I now rearrange this, so 3k equals k plus 6 times k minus 2. Expand out those brackets. Make it equal to 0. And there we go. We have done part A of that question. We could obviously solve that now. We could factorise that and find out that k will either equal minus 4 or k will equal 3. So let's just go back up there and check what would happen if we substitute those in here. If I substituted minus 4 in here, I'd get 3 times minus 4 is minus 12. Minus 12 over minus 6 would be 2, which would mean that the first term would be the same as the second term. And we're told that that can't be the case. A1 is not equal to A2. So therefore I know that minus 4 is not a solution to this. The answer must be minus 3. Now I know that k is equal to minus 3, I can substitute this in here and actually work out what the sequence is. So if I did that, so putting 3 in here, 3 times 3 is 9 over 3 minus 1. Second term is 2. The third term will be minus 3 over 2. Oops. So that's my first term, substituting 3 in here and here. That's the second term. That's my third term, substituting 3 in. And we know that these are going to keep on repeating and so on. The fourth term would be 9, the fifth term would be 2, the sixth term would be minus 3 over 2, and so on. We want the sum from the first number up to the 121st number. So if I need to add 121 terms here, well, I know that they appear in groups of 3. So I know that I will have 40 lots of these 3 terms would make 120 terms. And then I'd have one extra one on the end. So if I just work out the sum just of these, so that's going to be 9. 9 take away 1.5 is going to be, that's going to be 11. Take away 1.5, so that's all that's going to add to 9.5. So those 3 terms add to 9.5. If I have 40 lots of that, so 40 times 9.5 is 380. And then I need to remember that actually I didn't want to add 120 terms. I wanted 121 terms. So the 121st term would just be 9. Because if you imagine I've got 40 lots of this, which would take me up to the 120th term, and there'd be one term after that, which would be another 9. So my answer is 389.